Hi, my name is Noah Bailey, and welcome back to part 4 of my ECE5000 electrical engineering design project. This part is the testing phase of the project, where students show off the final code and a working system. As we discussed last time in the implementation phase, my project is a 120 volt AC load measurement device. It measures voltage, current, power, and energy, and it displays these four values on an LCD, as well as sending that data to an SD card, which can be ejected and observed on a computer. This project is entirely Arduino based, and in this case I'm using an Elegoo Uno R3, which is essentially the same thing as an Arduino Uno R3. And so let's jump in and start off by discussing what has changed since the last time. So the first major change that you will notice is that the design is now contained in the housing that we saw last time. And along with this came the installation of the Arduino Shield, which replaced the large breadboard that we were using for the test setup. And it is a much smaller shield, and it attaches directly to the Arduino. The Arduino Shield that was installed contains all of the digital and analog connections for the system, and any external components that were on the breadboard previously have been soldered directly onto this shield. So that includes the button, the resistor for the button, the resistor for the LCD, any corresponding wires for these two ground or 5-volt rails or digital pins, and also the potentiometer and the LED for the safe eject of the SD card. So all of these components, as mentioned, are soldered directly onto the shield. And the other connections are going directly into the analog and digital ports that are on the shield in the way of headers. Another big change since last time is that the design is now insulated for safety. This came in the way of heat shrink or electrical tape, and this covers any components that may have the potential to short circuit, which could cause damage to the system or to myself even. And so things like the voltage transformer, the current transformer were insulated, as well as wires were insulated, and so on, just to protect the design, make it a bit safer. The 4 probes that we saw previously that were used to measure the voltage and current of the load have been mounted to the housing, and they are insulated as well for safer connections. And not only are they insulated on the side of the housing, but they are insulated when it comes to where they connect to the load. So as opposed to last time where you saw me connect up the load, this time it's already connected up and insulated so that it is safer. Speaking of the load, a dimmer switch has been added to the load so that we can adjust the brightness of the bulb, in essence, and see how that changes the readings that we are getting, and see if that lines up with what they should line up as, which we'll see in the demo later on. Another thing to mention about the probes is that the left-hand side are for voltage and the right-hand side are for current. The positives for both are on the top and the negatives for both are on the bottom. Another minor change is that the power supply for the system has changed. It is no longer being powered by my computer, but by a 9-volt wall plug that takes the wall power, converts it down to 9 volts DC, and powers the Arduino via the power barrel, whereas last time, as I mentioned, it was powered by USB to my computer. The code hasn't changed since the last time, since everything was implemented last time and it seemed to be working as expected. And so we won't really touch the code too much today in the video, but it will be included in the report submission. So let's jump in and take a look at some of these changes on the actual design. Okay, so here I am showing off the design, and as we can see, it has been mounted into the housing. We have the voltage probes on the left-hand side, the current probes on the right-hand side, the LCD is mounted, and you'll notice here that the power supply is now connected to the wall as opposed to my laptop. Here's a little highlight of the load that is being measured, and we can see that the connections from the voltage and current are insulated now. Here's the dimmer switch that was added with an extra third ground for safety. But let's go ahead and tilt this housing on the side and look in the interior. We can see the voltage sensor on the left-hand side, the current sensor on the right-hand side. The SD card is just sort of hanging loose as we speak. The Arduino is on the bottom. You can see the button and potentiometer sitting on the Arduino Shield. And all of the connections for all the components are going into this shield. And as we saw, the LCD is mounted up. Here is another view of the Arduino Shield. The Arduino Shield has the potentiometer and the button, as well as all of the other connections for the design. This essentially just replaces the breadboard. You can see here I press the safe eject. And another cool fact is that the LED is now blue, whereas last time it was yellow. This is purely aesthetic. It means nothing in terms of the actual design, but the blue does seem to be much, much brighter. Alright, so I have pulled out the Arduino shield here just so that we can get a better view of it. And firstly, we'll notice that the shield essentially just extends the analog ports as well as on the other side here, the digital ports of the Arduino up and continues those female headers on. But it also adds in these 5-volt and ground female headers, which I am making use of here to connect all of my components. Also on the shield, you can see that I have soldered in the potentiometer, the resistor, the button, and the LED is also there, and there's also another resistor. Here I have detached the shield from the Arduino, and we can get a good look here at the bottom of the shield where some of the solder and wiring is. And then here's the Arduino, and I will just connect the two. You simply just line up the pins of the shield with the pins, corresponding pins on the Arduino. And bam, just like that, the two are connected. So this replaces the breadboard. Here we can see that the device is now turned on. We can see some of the insulation on the interior on the voltage and current sensor probes and wires. And then we can see the effect of the potentiometer. You can see as we adjust the contrast, the letters become clearer and less clear as the contrast of each individual character on the LCD is adjusted by the potentiometer. And then also you can see me here press the safe eject, the blue LED will light up, and then I will grab the SD card module and remove the SD here. As I mentioned, the code for the SD has not changed, and so the file will look identical to the last time. Now we are going to go ahead and jump into another small demonstration. So the first step is obviously to flick on the power bar. We'll see that the light comes on. And we can see on the LCD that we are reading some values. Now this is, I believe, a 50-watt bulb. And so these values align up with around what we would expect. They may be slightly off due to the sensitivity of the sensors. Now, as I turn the dimmer, which is essentially a potentiometer, we can see that the voltage has dropped significantly, as it should. And then we will turn it down even further, and we will see that the voltage drops again. The power has also gone down. The current stays about the same. And then we can turn it down to the point where the bulb is essentially off, and we get a very small voltage reading, very, very small power reading, around the same current draw. All right, so now that we've seen the updated project in its current state, we're back to asking ourselves, what is next for this design project? So in the future, I would like to essentially just clean it up and make it look pretty. Since all of the features that are required are already implemented and working as they should be, it's basically just a matter now of cleaning it up and making it look good. One thing that I would like to clean up is my housing. I would like to mount some of my components such as the voltage transformer or the current sensor. I'd like to mount my LCD screen a little better, and I'd like to clean up some of the wires in there, as the button and potentiometer can be a little hard to reach with all of the wires. Along with this comes cleaning up the Arduino shield, or perhaps even introducing a different proto shield of some type, so that I can clean up my wiring and my connections. And I may even go ahead and remove the female headers on the Arduino proto shield that was given and just solder directly into those parts there. Shorter wires, and will have the same effect essentially, but it will be much cleaner and prettier to look at. As I mentioned, the Arduino shield should be good for this project as it has plenty of space and it already has all the connections I need. I could just remove the female headers and solder directly into the board for some tighter and more permanent connections, or I could upgrade to something like this, which is just a different version of a proto shield, but it wouldn't have that ease of connectivity to the Arduino that the other one has. I'd like to continue to clean up the housing, label the ports, so the left side would be labeled voltage and the right side would be labeled current. I'd like to have the SD card be perhaps mounted or cleaned up a little. I'd like to paint the box or finish it in some type of way so that it's a little nicer on the eyes. Maybe add a lid just to cover it and keep those components safe on the inside. Like I mentioned earlier, the code has not changed since it worked last time in the implementation phase, and all of the features that we needed were implemented. But some aesthetic changes I could make to the code are, say for example, like I mentioned last time, the SD card file. I could change how it is written to the SD card file just so that it's a little prettier, a little nicer on the eyes. But once again, this is just aesthetic as it works the way it should. All of the data that needs to be sent is sent, but it could look a little prettier in my opinion. As I've mentioned a few times, everything that needs to be in the project is there and is working as expected. We even saw with the dimmer switch that as we turn the dimmer switch up, the voltage across the light drops, which makes sense because the dimmer switch is essentially just a really big potentiometer voltage divider. All the features work and are implemented as they should, and so now it's just a matter of cleaning it up, making it look presentable, and making it look pretty. Thank you for watching. I hope you enjoyed. Once again, I am Noah Bailey, and this was my ECE5000 Electrical Engineering Design Project Part 4 testing, and I look forward to seeing you in the next part for the finished product.